You were taught that light is one of the most understood things in physics. That is false. And the reason it's false matters more than you think. We can calculate how light moves with extreme precision. We can predict exactly where it will land. We can build technology that depends on it down to the atomic scale. Physics does all of that flawlessly. And yet, we do not know what light is, not in the way knowing is supposed to work. Most of physics follows a simple pattern. You identify an object, you describe its properties, you explain how it behaves. Light refuses to follow that pattern. Test it one way, and light behaves like a wave. It spreads, it interferes, it overlaps with itself. Test it another way, and light behaves like a particle, discrete, localized, countable. This is not a metaphor. This is not a limitation of our instruments. Light is not switching costumes. It is answering different questions with different realities. For decades, physicists tried to make peace with this by saying light is both a wave and a particle, a phrase that sounds like an explanation, but is really an admission of failure, because nothing in classical reality works that way. Richard Feynman understood this problem better than most. He didn't call it confusing. He didn't call it incomplete. He called it the central mystery of quantum mechanics. Not because the mathematics fails, the mathematics works perfectly, but because the moment you try to imagine what is actually happening, every classical picture collapses. Here is the uncomfortable truth. Light does not move through space the way objects move through space. It does not carry a fixed identity with it. Its behavior is not decided in advance. Light responds to the structure of the situation itself, less like a bullet traveling through space and more like a rule being applied. And that leads to a deeper problem. If light behaves according to rules built into the situation, then reality is not constructed from things first. It is constructed from rules, invisible constraints that exist before matter moves, before energy flows, before cause even looks like cause. When physicists finally followed this idea to its limit, it led them to a single experiment, an experiment so simple it fits on a tabletop, and so destructive that it shattered every classical idea about reality. 2 slits, one particle at a time, and a result so unsettling that it forced a question physics still cannot escape. Does observation change reality, or does it reveal that reality was never fixed to begin with? This version is locked unless you find a specific flaw, word, sentence, logic, or flow. If you do, point to the exact line. To understand why that question is unavoidable, you have to look at what the experiment actually does. Not in theory, not in metaphor, but step by step. Imagine a barrier, solid, opaque. Nothing passes through it. Now cut 2 narrow slits into it. Just wide enough for something to get through. Just narrow enough to control what happens next. On one side of the barrier, a source of light. On the other, a screen to catch whatever makes it through. Nothing exotic so far. This is basic physics. If light were a particle, each particle would pass through one slit or the other. You would expect 2 clusters on the screen, one behind each slit. Simple, predictable, classical. But that is not what happens. Instead, the screen fills with a pattern, bright bands, dark gaps, repeating structure, an interference pattern, the unmistakable signature of a wave. Light behaves as if it passes through both slits at once, spreads out, and interferes with itself. So far, this is strange, but not shocking. Waves do this all the time. Now remove almost all the light, so little that only 1 photon is emitted at a time. Not a beam, not a stream, a single particle. Send it toward the slits, 1 photon, 1 event. At first, the screen shows nothing meaningful, just isolated dots, random impacts, exactly what you would expect from particles arriving one by one. But wait, as more photons are sent, the dots begin to accumulate, and slowly, unmistakably, the same interference pattern appears, not because photons are interacting with each other. They are sent one at a time. Each photon is alone, and yet together they draw the pattern of a wave. This is where classical reasoning breaks, because for that pattern to exist, each photon must behave as if it goes through both slits, not metaphorically, not statistically, individually. At this point, the obvious response is to watch more closely. So detectors are placed at the slits, devices designed to answer a simple question. Which slit did the photon go through? The moment that question is asked, the pattern disappears. The interference vanishes. The screen now shows exactly what particles should produce. 2 clusters. No waves, no overlap. Nothing else changed. Not the slits, not the screen, not the photons. Only the availability of information. If the path is knowable, light behaves like a particle. If the path is unknowable, light behaves like a wave. Not because it is switching behavior, but because the structure of the situation has changed. This is the point Feynman warned about. Because the experiment does not tell you what light is. It tells you something far more disturbing, that the outcome depends on what questions reality is allowed to answer. The photon does not arrive carrying a fixed story. There is no hidden label saying wave or particle. There is only a response to the constraints imposed by the experiment itself. And that leaves a problem no interpretation can avoid. If the result depends on whether information could exist, not whether anyone actually looks, then the behavior of light is shaped before observation ever occurs. Which means the question is no longer about light. It is about reality, about whether the universe waits for answers before deciding what happened, or whether it was never decided at all. The double-slit experiment doesn't confuse physics. It exposes its limits, and whatever comes next will not make things simpler. It will make them unavoidable. At this point, most explanations try to escape. They introduce hidden variables. They imagine secret instructions carried by particles. They search for a classical story hiding underneath the math. Richard Feynman went in the opposite direction. He stopped trying to picture what light does and asked a different question. What if light doesn't choose a single path at all? In classical physics, motion is simple. An object starts here, it ends there, and it follows one definite path in between. Quantum physics refuses this simplicity. According to Feynman's formulation, a photon traveling from one point to another does not take one path. It takes every possible path, not just the straight line, not just the sensible ones, every path imaginable, including paths that loop, wander, and double back, including paths that seem absurd. This is not poetry. It is a precise mathematical rule. Each possible path contributes to the final outcome. Each one adds a tiny influence. Most of those influences cancel out. They interfere destructively. But a few reinforce each other, and what survives is what we observe as the behavior of light. This is why the double-slit experiment works. The interference pattern is not created by light splitting in two. It is created by paths interacting with paths. When both slits are available, entire families of paths exist. When one slit is blocked, those paths vanish. Change the allowed paths, and the outcome changes automatically. No decision required, no signal sent, no observation needed. This reframes the mystery. Light is not asking, am I a wave or a particle? It is responding to a deeper rule. Which paths are allowed to exist? This is also why trying to catch the photon fails. The moment you place a detector at a slit, you are not merely watching. You are removing paths. You are changing the structure of what is possible. And when those paths disappear, so does the interference. In this view, nothing collapses mysteriously. Nothing switches behavior. The experiment changes, and reality follows the new constraints. Feynman was clear about one thing. This way of thinking does not explain why nature works this way. It only tells you how to calculate what will happen, and it does so with astonishing accuracy. More accurate than any theory ever tested. That success creates a deeper tension, because the math knows exactly what to do, but it refuses to tell a story the human mind can visualize. There is no picture of a photon taking all paths. There is only a rule that works, whether or not it makes sense to us. And that raises the next problem. If reality is governed by rules over paths, not objects moving through space, then what we call space may not be what we think it is at all. It may not be a stage where events happen. It may be part of the rule itself. And once that idea enters physics, the mystery no longer belongs to light. It belongs to the structure underneath everything. And that structure does not behave like anything in our everyday experience. At this stage, something uncomfortable becomes impossible to ignore. The rules work perfectly. Using nothing but these abstract constraints on paths, physicists can calculate how light behaves with a level of precision that borders on the absurd. Every decimal checked, every prediction confirmed. No theory in the history of science has been tested more accurately. And yet no one can explain what the mathematics is actually describing. This is where physics quietly changes character. It stops being a story about what exists and becomes a procedure for getting the right answer. You follow the rules, you perform the calculation, you get a number, and the number is always right. Richard Feynman was unusually honest about this. He never claimed the math revealed reality's inner picture. He said something far more restrained. He said it tells you how to compute what will happen, not what is happening, not why it happens, just what the outcome will be if you set the situation up a certain way. This creates a strange divide. On one side, prediction, flawless, reliable, unquestionable. On the other, explanation, fragmented, metaphorical, disputed. The equations do not care which interpretation you prefer. They produce the same results regardless. Physicists have tried to bridge this gap for decades. Some say the wave function is real. Others say it is just information. Some say every possibility happens in parallel worlds. Others say reality only exists when measured. These interpretations disagree about everything except one thing. The math stays the same. That is the quiet truth hidden inside quantum mechanics. Reality is not defined by the stories we tell about it. It is defined by a structure that responds to constraints, produces outcomes, and refuses to explain itself. This is why light still feels mysterious. Not because we lack equations, not because experiments fail, but because the deepest layer of physics does not offer a picture of the world. It offers a rule book, and the rule book works whether or not we understand what it means. At some point, this forces an uncomfortable realization. If the mathematics predicts everything we can observe, and interpretation changes nothing, then perhaps understanding, as humans usually mean it, is not something physics is designed to provide. And that raises the next question. If physics cannot tell us what reality is, only what it does, then what exactly are we learning? When we say we understand the universe, and how much of our need for explanation is something nature never promised to satisfy? At this point, most misunderstandings come from a single habit the human mind refuses to give up. Visualization. We want a picture, a shape, a motion we can imagine happening in space. Physics trained us to expect this. Planets orbit, balls collide, waves ripple through water. So we try to do the same with light, and that is where things go wrong. Every time someone asks, "But what is the photon really doing?" what they are asking for is a picture their intuition can recognize. Quantum mechanics does not provide one, not because it is incomplete, but because no such picture exists. The wave function is not a physical wave moving through space. It does not ripple like water. It does not oscillate like a string. And the photon is not a tiny object traveling along a hidden trajectory. Both images are wrong in the same way. They take a mathematical rule and turn it into a story it was never meant to tell. This is why so many explanations fail. They replace precision with comfort. They say the particle decides, or the wave collapses, or the photon chooses a path. These words feel explanatory. They are not. They smuggle human intuition into a domain where it does not apply. Feynman warned about this directly. He insisted that you should not ask how quantum behavior can be visualized, because the demand for visualization is the source of the confusion. The theory does not describe objects moving in space. It describes relationships between possible outcomes. This is the lie of visualization, the belief that understanding means seeing. In quantum physics, understanding means calculating correctly without pretending the calculation represents a picture. Once this is accepted, many familiar questions dissolve. Which slit did the photon really go through? What was it doing before measurement? Where was it in between? These questions assume there was a definite story waiting to be told. There was not. The theory does not say the answer is hidden. It says the question does not apply. And that distinction matters. When physics abandoned visualization, it did not lose predictive power. It gained it, but it lost something else. The ability to tell a story that feels intuitively true. And that loss is not a temporary gap. It is a permanent feature of the theory. Because the quantum world is not obligated to make sense to a mind shaped by classical experience. This is why light still feels impossible to grasp, not because it behaves strangely, but because it refuses to become an image. And once you stop demanding one, a different problem comes into focus. If reality cannot be visualized, but only constrained and calculated, then what exactly is the role of observation? And why does it seem to matter at all? By now, the pattern should be clear. Quantum physics does not fail at prediction. It fails at satisfying a particular kind of curiosity, the kind that asks for meaning, for mechanism, for a story that feels complete. Physics is extraordinarily good at answering one question. What will happen if the situation is set up this way? It answers this with numbers, with probabilities, with outcomes you can test and confirm, and it never misses. But there is another question people keep asking. Why does reality work this way at all? Why these rules? Why this structure? Why a universe where outcomes depend on constraints rather than objects carrying fixed properties? On that question, physics goes silent. Not because the question is foolish, but because it points beyond what physics is built to do. Physics does not explain why the rules exist. It discovers which rules are consistent and which ones match observation. It is a map, not a justification. This is where confusion often creeps in. People expect physics to provide both prediction and purpose. But those are different demands. The theory tells you how reality behaves when you interact with it. It does not tell you why reality allows such behavior in the first place. Feynman was blunt about this limitation. When pressed for deeper explanations, he didn't invent stories. He stopped. Because inventing a story would have been dishonest. At the deepest level we can reach, physics offers something precise and something incomplete. Precise rules, incomplete meaning. It tells you how to calculate amplitudes, how to predict distributions, how to engineer outcomes. It does not tell you why the universe permits those rules instead of others. This is not a failure waiting to be fixed. It is a boundary. A line between what can be modeled and what can only be acknowledged. Once you reach that line, you are forced to confront an uncomfortable idea. Maybe explanation, as humans usually mean it, is not a fundamental feature of the universe. Maybe it is a preference, a demand imposed by minds that evolved to navigate a classical world. Physics does not promise comfort, it promises consistency, and it keeps that promise relentlessly. So when we say physics can't explain light, what we really mean is something narrower. Physics cannot turn quantum reality into a story we can intuitively accept. It can only show us what happens when we ask certain questions and forbid others. And that leaves one final tension unresolved. If observation does not create reality, and visualization does not describe it, and explanation does not reach its foundation, then what role do we play at all? Are we discovering a structure that exists independently of us? Or are we participating in a process where the questions themselves shape the answers? That is where the story ends, and where the last part begins. At the end of all this, something becomes unavoidable. Light was never the real problem. It was only the place where the problem became visible. We started by asking what light is. That question failed. We tried to picture it. That failed too. We replaced pictures with rules, and suddenly the predictions worked better than anything physics had ever known. But the cost was clarity. Not mathematical clarity, human clarity. What quantum physics revealed is not a strange behavior of light, but a strange feature of reality itself. Reality does not begin with objects. It begins with constraints, with rules about what is allowed to happen and what is not. Matter moves because those rules permit it. Energy flows because those rules allow it. Causes follow effects only because the structure makes it possible. Light does not travel through space like a thing moving across a stage. It behaves the way it does because space itself is part of the rule, not an empty container, not a passive background. an active structure that shapes outcomes before anything occurs. This is why explanation keeps failing. We keep asking for a story about things. In a universe that is built from relations, we keep demanding images in a reality that only responds to constraints. We keep searching for meaning in behavior when the deepest layer offers only consistency. Feynman understood this tension. He didn't try to resolve it. He accepted it. The theory works perfectly. And the price of that success is giving up the belief that nature must make intuitive sense to us. This is not a defeat. It is a shift, a recognition that understanding does not always mean picturing. That explanation does not always mean mechanism. That knowledge does not always come with comfort. Light is not mysterious because it behaves strangely. It is mysterious because it reveals the kind of universe we actually live in, one where rules come first, where objects are secondary, where asking the wrong question creates the illusion of confusion. Once you see this, the mystery does not disappear, but it changes. It stops being a problem to solve and becomes a boundary to respect. And that may be the deepest lesson physics has to offer. Not that reality is unknowable, but that it is knowable only on its own terms, and those terms were never designed to feel human.